Now, my hope is today this is going to be easy. So today, 4, 11, 22. Our objective today is to simplify or reduce roots. And in math, we call them radicals. That's the math word for them, radicals, okay? Okay, example 1. What I want to do is look at this problem in 2 parts. I've got a number and I've got a variable. So I'm going to rewrite example 1 as the square root of 27 times the square root of x to the 8th, okay? The square root of 27 actually has one of these nice numbers in it. Now when I say one of these nice numbers in it, the square root of 27 can be something times something. Something times something makes 27, but let's use one of these numbers because obviously 27 has a perfect square. So if I rewrite 27 as the square root of 9 times the square root of 3, I'm going to use one of my perfect squares. So I'm going to take and I'm going to rewrite 27 as the square root of 9 times the square root of 3. Okay? Yeah, Gabe?
Did you just write 3 times the square root of 3?
You're ahead of me. I like that. That's what I'm going to write. Exactly. So we know what the square root of what 9 is. Square root of 9 is plain old 3. I agree with Gabe. So the square root of 9 is 3. But this square root of 3, the square root of 3 is really a bad number. Square root of 3 is that. So I agree with Gabe. Let's not write 1.73205 blah, blah, blah. But let's write the square root of 3 times the square root of 3. Okay, so I kept the square root of 3 as square root of 3. It's a much nicer number than that decimal. Now, we've done the first part. The second part with variables is this. We've learned that a square root is the same thing. We learned this last year as well, that the square root is the same thing as a 1/2 power. Okay, we've learned that last year whenever, but the square root, because there's a little invisible 2 right here that we never write. And if we take half of 8, it becomes x to the 4th. So let's see, let's make a little rule. So with exponents, we always take half the exponent. So I took half of it. All right, now, half of x to the 8th is x to the 4th. So when I take square roots, when I do the root, when I do the process, when I take the square root of 9, it's done. It's out of the square root. I'll say it again. When I do the process, when I do the root, square root of 9 is 3. It's done. It comes out. Does that make sense? Pull it out of the square root. When I take half of the 8, when I'm taking the square root of x to the 8, it is done. It comes out of the square root. Now what's left? These 2 are out. The 3 and the x to the 4th are out. We've reduced it. We've brought some things out of the square root, so we're left with an answer of 3x to the 4th times the square root of 3, okay? Thumbs up. Do you remember that from last year at all? Okay, I see one thumb up because you just did geometry, right? All right, let's go through example 2 when you're ready. We'll go through it slowly, okay? Okay, example 2. First of all, in example 2, golly, I keep trying to block all these. How do these people, anyway, continue, I'm recording. The 3. So in this problem, the 3 is done. It's already outside the square root, right? So I'm just going to write the 3 down. Leave the 3 there, but we don't have to do anything with it. It's just a whole number 3. But the 18, square root of 18, square root of x to the 7th. Gabe, go ahead. I'm listening.
That one, can you do, not x, sorry, 9, the root of 9 times the root 2?
Yes, absolutely. I want to use 9 and 2. I do not want to use 3 and 6. Perfect. In fact, it would be really dumb to use 3 and 6. You guys agree? There is no square root of 3. There's no square root of 6, but there is a 9. So I'm going to rewrite just like Gabe said. I'm going to go the square root of 9 times the square root of 2 because I can take the square root of 9. Now, if I want to take half the exponent, okay, I want to take half of this. I can't take half of 7 without getting a decimal. So I'm going to take 1 away. Take 1 away and rewrite x, 6, and x to the 1, okay? So we want to take half of the exponent, but to make it even, so we take half of it, I took 1 away to make it even, okay? So 6, if I take 1 away from the 7, I get a 6. I can take half of that, and then the 1 left over, okay? Now, we can take some square roots. So the first square root I'll do is take this 9. This 9 becomes a regular 3. I'll take half of my x to the 6, have it as x to 3, okay? I have a little bit of a mess, but I'm going to tidy it up, okay? I'm going to tidy it up. I took the square root of 9 as 3. I took half this exponent. What's left over? Well, this 3 times this 3 makes a 9, okay? So I'm going to get an answer of 9 x to the 3rd. And these two roots, the square root of 2 and the square root of x, cannot be done. You cannot take the square root of 2 or the square root of x, so we leave them inside the radical sign. Okay, is this coming back to you at all from geometry? Maybe a little bit? That's why.
Yeah, I was going to say that.
Okay. Okay, example 3. Let's just multiply. Okay, 15 times 5. What is 15 times 5?
75.
I think it's 75, isn't it? Square root of 75. But can I do anything with that? Square root of 75. Can 75 be either of these numbers?
No.
25.
Yeah, 25 times 3. You guys agree with Michael? So I'm going to rewrite this as the square root of 25 and the square root of 3. I can take the square root of 25, right, and bring it down to 5. The square root of 3 will leave as the square root of 3 because the square root of 3 is a really bad number. Square root of 3 is that. No, I don't want that number. I want just leave it square root of 3. So what I've done is I multiplied them, and then I reduced it. That's all I can do. Okay, example 4. Am I going too fast? I'll wait for you. Example 4, I'm going to multiply. There's no plus or minus multiply, but let's multiply whole number with whole number, square root number, square root number, okay? So whole number with whole number. So I'm going to go 2 times 4 is 8. And then square root number with square root number, square roots of 18. Okay, now what? Well, just like Gabe said before, remember when Gabe had the 18? And Gabe broke up the 18 into 9 times 2. I think I want to do the same thing with this 18, right? I can reduce that. So let's find good multiples. 18 and 2 or 9 and 2 are great multiples. So I'll go 8. And I'll go square root of 9, square root of 2, because that makes my 18. And then the whole idea is then we can reduce it. We take the square root of 9 as 3. And then I am multiplying. 8 times 3 is 24. Square roots of 2.
Wait. What? Oh, I get it now because the mouse. Okay.
Okay, good. I want you guys to stop me, think about it. I mean, you might have learned this last year or last semester, who knows, but it's probably long forgotten for some of you. It's all right. I don't mind doing it again. He said, number 5. Here's the deal with square roots. They're like x's. You cannot add them unless they're the same. You cannot add square roots unless they're the same. So you can't add those. Not yet. You can't add them at all. Not yet. Why do I say not yet?
Because that's our goal.
That's our goal. So what do you know about 8? What do you know about this number 8?
2.
And 4. 4 and 2, square root of 4, square root of 2. I agree with that totally. There's my square root of 8 plus 5. What about the square root of 18? What can we rewrite that as?
9 and 2.
Yeah, square root of 9 and square root of 2. Awesome. Okay, I'm getting somewhere, I think. So then I know what the square root of 4 is. That's a 2, and I know what the square root of 9 is, that's a 3. It's a multiplication process. 3 times 2 makes 6 square root of 2 plus 15 square root of 2, and now I can add them because they are the same. So 6 square root of 2 plus 15 square root of 2 is not square root of 4. Not. It is 21 square root of 2. How many square roots of 2? How many square roots of 2? 6 square roots of 2 plus 15 square roots of 2 makes 21 square roots of 2. Okay? I can add them. All right, number 6. It's just distributive property. When we know this, I would take and have like, I don't know, 3 times x plus 5. And you go that times that right? Or do the same thing. We're going to distribute. Let me make these parentheses a little bit bigger. I mean, when I type it out, it doesn't look that big, right? So if I make these parentheses a little bit bigger, it's a little easier to see. So you're going to get that, like that. So then I'm going to go 3 square roots of 3 times 2 square roots of 6. 3 square roots of 3 times 5 square roots of 3. All right. Whole numbers times whole numbers. 6 square roots of 18 plus 5 times 3 is 15 square roots of 9. Okay, that's all I did. Multiplied whole numbers with whole numbers, square roots of square root numbers. Now, hopefully you see something. We keep this square root of 18 keeps popping up, right? We've done it a couple of times, so let's break the 18 up in the same way. 9 and 2, right? So I'm going to reduce the 18 to the square root of 9 and square root of 2. Oh, this is nice. What's the square root of 9?
3.
Plain old 3, isn't it? Just a plain old 3. You guys agree with that? Just 3, not the square root of 3. It's just 3. Square root of 9 is, boom, 3. Okay. Here I can take the square root of 9. That's a 3. This is a multiplication process. 6 times 3 is 18. Square root of 2 plus 15 times 3 is 45. Now these you cannot add. Only add like terms. Add like terms like I did over here. But if they're not like terms, you're done. Okay, that's my answer. Can't add them if they're not the same. All right, example 7 is a FOIL problem. It really is. So I mean, you know, if it's a problem like this, you know, if I had like 2x plus 1 times a 3x minus 4, I would just, you know, that times that, that times that, that times that, that times that, right? We'll do the same process, except for it's the square roots, right? Same process, we're going to FOIL it. I'm going to go 2 square roots of 3 times 5 square roots of 3, 2 square roots of 3 times negative 5, and then 1 times 5 square roots of 3, and then 1 times negative 5. All right, so we'll have 10 square roots of 9 minus 10 square roots of 3. Whole number with whole number, and then bring the square root along. Positive 5 square roots of 3 minus 5. I think the two middle terms can be combined because they're both square roots of 3. I see a square root of 9. I know the square root of 9 is plain old 3, right? That is a multiplication. I'll take 10 times 3 is 30. The middle two terms are the same. I can subtract them. Negative 5 square roots of 3 and a positive 5 square roots of 3 makes a negative 5 square roots of 3 minus 5. Almost done. Why not go 30 minus 5? Those are whole numbers, right? Those are whole numbers. 30 minus 5 is 25 minus 5 square roots of 3. Since they're not like terms, we can't add or subtract them, so we're done. What do you think? Okay, ready to turn the page? I'll wait for you. I'll turn the page.
Brain break.
Not yet. No, I don't know about brain breaks. You guys just wander the halls. Okay. All right, example 8. This one's actually not that hard. This is the same thing as the 5th root of 32 squared. Gabe. Yeah, go ahead.
Four.
It is 2 squared, which is 4, okay? So I wrote it as the 5th root of 32. What Gabe saw was the 5th root of 32 is 2. You guys agree with that? And then 2 squared is 4. Good job, Gabe. Yes, Gabe.
Does it matter if the square is inside or outside of the radical?
It does not matter at all. In fact, I want to answer that. I think you'll agree with me. If I put it here, I'd have to square 32 first. And I'd have to figure out what the 5th root of that number is. Or do that first, right? And then that. So no, it doesn't matter at all. Yeah. I much prefer to do it the other way though. You agree? Yeah. Okay. Thanks, Gabe. Good job. That's 4. How about number 9? What do you guys think? What's the answer to number 9? What is it? Yeah, Gabe?
Sorry, just one thing. For the last one, number 8, so can't you also just go to the, so like it is 2 times 2, like itself 5 times. So can't you just go to the second time it's multiplied by itself?
Say that again, maybe.
So basically, like, it's 2 times 2 times 2 times 2 times 2.
Yes.
So it's just wanting,
2 of those. Oh, yes, yes. Let's not go there. Totally correct. I see what you said. So it's 2 times 2 times 2 times 2 times 2. We only really want 2 of the 5 or 2/5 of that. Yes. Brilliant. I don't like to teach it that way, but brilliant. Yes. Okay. Nice job. How about 9? Let's make it easier. That was really well done. How about number 9? Answer. Go ahead, Gabe.
9.
How did Gabe get 9? Well, the cube root of 27 is what times what makes 27? 3. And 3 squared is 9. Nice job, Gabe. All right, number 10. Let's just solve. Divide by 2, divide by 2, x cubed equals 30, right? Cube root. And we get 1 of 2 answers. We're either going to have x equals the cube root of 30, which I don't mind that answer at all, or we'd have to have a decimal answer. I don't really want the decimal answer, but sometimes we have to have a decimal answer. So I go into my math button in my calculator, and there's a cube root button here. Enter, I go 30, or sometimes we could call it 3.12 or approximately 3.12, okay? I like this answer better. How about you guys? Okay, almost done. Example 11, I'm going to square root. Don't go plus 5, plus 5. I'm going to square root both sides first. Okay. I'm going to get an x minus 5 equals plus or minus the square root of 50. And you know why I put plus or minus, don't you? How many answers should there be? Should there be 2 answers? Right? Or x minus 5 equals plus or minus the square root of 25 square root of 2. Or x minus 5 is equal to plus or minus 5 square root of 2. Now I'm going to go plus 5, and I'm going to have x equals 5 plus or minus 5 square root of 2. Or a decimal answer, but I sure like that answer better than a decimal answer, okay? All right, so I have a homework, and the homework is a homework sheet I gave to geometry kids, which is okay if we do a geometry homework today, right? Okay, it's okay. It's super sloppy because I didn't want to type it up. Don't call me lazy. I worked pretty hard. I'm like kind of thinking, well, you know, backing up to geometry, so I don't want to type this up because I'm hoping I won't have to use this again next year, right? Because code will be fast, code will all be brilliant.
So we're going to increase it again.
Well, if it does, you know, we're going to live with it, I guess. Probably will be a seasonal thing.
What about like
Okay, so let's get started on this. Everybody, we got time, let's get going.
really?
Every problem, I'm gonna work with you. Okay, let's start. I'm gonna start with this. I'm gonna start with you. I'm gonna go super slowly. I thought this thing stopped. Stop.